Okay, so 8-2 is quadratic functions. Like I said, this is very similar to 8-1 with just a slight variation. And so what we're going to be doing in this lesson is we are going to be graphing a parabola and just practicing that method. We only have two big problems, and then we have a few shorter problems to do. And then we do have one word problem. And I would say that the word problems were the most challenging on the first lesson. So we'll go slow on this one. We only have one to do in the notes, but you do have two to do on the homework. So we are going to go over the steps for this because they are step by step right here. They're gonna sound just like the ones we did in lesson 1-1. And then I'm going to go over some parabola properties. Okay, some of the things that you can look for, and then we'll go ahead and get started on the notes. All right. So when we're graphing a parabola, with the lesson 1, we just used -1, 0, 1, right? We used just those. And that was because, does anyone know why we just used those? What were we missing from the quadratic equation where we could do that? Anyone remember?
We're having a wardrobe malfunction.
Oh, no. Does anyone know what we were missing from that quadratic equation? What if oh, go ahead. Huh? The bx, right? So we have y equals ax squared plus bx plus c. Well, in 8-1, we were missing this middle term. Well, when you miss this middle term, then you know that parabola is going to go straight through the y-intercept, and you can use -1, 0, and 1 for certain problems, and then you could just use 0 for x to find the y-intercept and other problems. Well, in this case, we have a full quadratic equation, including our bx, and we do not know where that vertex is. It could be anywhere on the graph. And so what we do is we use a formula called the axis of symmetry formula, where we can find our x of the vertex, then plug that x into the equation to find the y of the vertex. Once we have that vertex, we choose 1 point on either side of it to form a parabola. So the difference is we have to start out with the axis of symmetry to figure out the vertex, which is that center point of the parabola. Okay. Once we find that x coordinate from step 1, we substitute it in to find y. And this is your first point. Then you'll find 2 additional points on the graph by choosing 2 x coordinates and solving for y. A lot of people say, how do we know which points to solve or to use? You're going to choose one above and one below the vertex, the x of the vertex, and I'll show you how to do that. And then you just graph it and you sketch your parabola. When a graph opens up, it'll read with a positive a. Okay, so your parabola will open up like this. If it has a negative in front of the a, you know your parabola is going to open down. Okay, so that's really, if you have a positive a, open up. If you have a negative a, it's going to open down. Okay. And then the c in the equation represents where the parabola will cross the y-axis. Okay. So if you have this equation right here, you plug 0 into the x, you have 3. So we know that the parabola is going to cross the y-intercept at 3. Okay. And so let's go ahead and go to our first example. When you're doing your homework, please follow these examples. I have done one problem on one page with each step as we're going to do that. Okay, so here we have it. We are going to graph this quadratic equation, and we first have to find the vertex. In order to find the vertex, we have to find the x of the vertex, and then we're going to find the y. So we find the x by using this equation right here. Okay, so I'm going to write this down. x equals -1b over 2a. Now you do not have to put the -1. You could just put the -b. However, I put the -1 so that it doesn't confuse you, that if your b is negative, that you know to multiply -1 times the -6. Okay, so and remember, there's a 1 right here in front of the x squared. I'm going to zoom in a little bit. The 1 represents A, the 6 represents B, the -6, and the +4 represents C. Are there any questions so far? Okay, so now what I'm going to do is I'm going to plug each value into my axis of symmetry equation. So I have -1 from my formula. I have a -6 for my B, so times -6. That's going to be over 2 for my formula times A for my equation. A is 1. And then I just solve this, okay? So -6 times -1 is a +6. 2 times 1 is 2. And then 6 divided by 2 is 3. So what is this 3 again? Why did we do that? Yeah, so David said to find x of the vertex, and then Esther said to plug it back into the quadratic equation so that we can solve for y of the vertex. So here we have x equals 3. Okay. So now what we're going to do, it says when you find the x coordinate from step 1, substitute it into the equation for x to determine y. This will give you an ordered pair for your first point, which is your vertex. That is your first point. Okay, so let's go ahead and do this. I'm going to rewrite my equation. Y equals x squared minus 6x plus 4. And I'm just going to take this 3 and I'm going to plug it into the x here and the x there so I can solve for y. So y equals 3 squared minus 6 times 3 plus 4. And let's go ahead and solve this. And you should get y equals -5. Okay. So your vertex is 3, -5. So now let's look at step 3. Step 3 says find 2 additional points on the graph by choosing 2 x coordinates and solving for y. Use 0 to determine the x-axis ordered pair and then another value for x. So I'm going to go ahead and write out a table. Remember, I like to have 5 points. You really only need 4. Okay, but our middle, our axis of symmetry is going to be 3, -5. So I'm going to go ahead and write this right here. Okay, now it says to choose 2 additional points. I'm going to choose 4 additional points. You can choose whatever you want. I am going to choose, well, it does say use 0 to determine the x-axis, so I am going to choose 0 right here. Actually, I'm going to choose 0 right here. I'm sorry. And then I'm going to choose 2. And then I'm going to choose 4 and 5. Okay. So 0, 2, 4, and 5, or 2. Yeah. So the reason I choose 0 is so that we can get an x-intercept. So let's go ahead and solve for all of these right here. So I'm just going to use my equation. and solve for those. So I want you guys all to do that on your own, okay? So I'm gonna go ahead and pause the video. Go ahead and find all of your ordered pairs. Okay, so here are my ordered pairs. Now, when I did this, I got 4, -4, -5, -4, -1. So what I did was I also found 1. And that would go in between the 0 and the 2, and I got a -1, and this is gonna form the parabola. So I'm gonna go ahead and for 4 and 5 right here. So 4 squared is 16. -6 times 4 is a -24 plus 4. Okay. All right, so let's plot these points. We have 0, 4, 2, -4. I also figured out 1. So if x is 1, it's -1. And then 3, -5, 4, -4, 5, -1. And what if I would have chosen 6? Does anyone know what it would be if I chose 6? So if I have 1, -1 over here, I would have had 6, -1 up here. Okay, so here's my parabola. I'm going to sketch it. So in step 4, it says graph the vertex you discovered in step 2, which we did, the 2 additional points you found in step 3, and then reflect the 2 points from, okay, we're not going to do that part. Okay. That's all we're going to do for this one. Okay. So that is how you graph a parabola when you have a full quadratic equation. Are there any questions? Okay. Okay, so there was a question asked, where did I get my 1, -1? And so what I did, since I skipped 1 right here, I went ahead and solved as if I had an x, a 1 for x, and I got -1. And then I added 6 at the bottom, and when I solve for 6, I also get a -1. So I just added 2 more points to my parabola. It's not required. Unless you're asked for the y-intercept, then you do need to figure that out. Okay, so we're going to go ahead and move on to example 2. And what I would like for you guys to do is I want you to try to use this axis of symmetry equation on your own. So using the quadratic equation that you're given, find the axis of symmetry. Okay, so everybody's going to work on that right now. And then I'm going to pause the video. So if you're watching the video, go ahead and pause that and try to work out your axis of symmetry. Okay, go ahead and check to make sure you got the correct answer for your x of the axis of symmetry. And then what I want you to do is I want you to do step 2. When you find the x coordinate from step 1, which is -1, substitute it into the equation for x to determine the y of your vertex. Okay. So I want you all to do that. And if you forget how to do that, look at on the previous page at our example to see if you can figure out how to do that. All right. So I'm going to pause the video. Okay, check to make sure your y of your vertex is correct. So you should have a vertex of -1, -3. And when you get that vertex, that means that's going to be your center point. So I'm going to show you something a little bit different than I showed you on the first one. So I have an X and I have a Y. Okay. And remember, you really only need 3 points. So I'll go ahead and do just 3 points on this. And I'm going to plug my vertex into that middle section because that is going to be our most center point. And to make it easy, all you have to do is do 1 less than -1, which would be 0. And 1 more than -1. Oh, that was wrong. 1 less than -1 is a -2. And 1 more than -1 is a 0. And so if you just do 1 less and 1 more, you'll have 2 points on either side and you can solve that way. So are there any questions about that part? I may have confused you a little bit on the first one. So what I want you to do is I want you to go ahead and find the y value for each of these x values by using the quadratic equation up at the top. And I'm going to pause the video so you can work those out. Okay, go ahead and check your table. And let's go ahead and then graph your parabola. Now remember, these are not V's. That's a lot of times that's why I choose 5 points, because when you choose 3 points, they look like V's. But just kind of make this a U shape. And this is what your parabola should look like. And then again, we're not going to reflect. We're not going to do this part. Do that on our system. Okay. Any questions? All right, let's go to the back. I believe on the back, we are just going to find the vertex. So we're not going to do any of the graphing or the table. Okay, so it says find the equation of the axis of symmetry and the coordinates of the vertex of the graph of each function. So we have to find the vertex. Based on what we just did, what is our first step in finding the vertex? Right. We're going to use the equation x equals -1b over 2a. And we're going to find the x of our vertex. So let's go ahead and do that. So we have -1 times our b, which is -8. Remember to carry that negative with the b. So -1 times -8. And then we have 2 times our a. Our a is 1. We solve this. And x equals 4. Okay, can somebody else tell me what we're going to do next? Yeah, we're going to plug this into the x here, into the equation that we're given to find y, and then we have our vertex. So y equals 4 squared minus 8 times 4 minus 7. So we have our x and we have our y. So we have our vertex. Just 4, -23. See why we didn't group this one? Our graph doesn't go to -23. Yep, that's all you're going to do for these 4. And that's actually what you do on the first 6 of your homework, and then you only graph 7 through 10 on your homework. Oh, and you graph 11 and 12 on your homework. Okay. So let's go ahead and we're going to do 4 and 5. And then you're going to do 6 on your own. Okay. So actually, I'm going to have you do 4 on your own. Okay. Do 4. 5 might be a little bit different because it doesn't have a BX, kind of like what we did in 8-1. But we'll go ahead and do that one together. So do number 4 on your own. I'm going to pause the video. Check number 4. Any questions on that one? Okay. If you look at number 5, you'll notice there is no BX. So anytime you come across something like that, when you plug in for your axis of symmetry equation, it's 0. That's all it is. So it'd be -1 times 0 over 2 times 2, which is 0 over 4, which is 0. Okay. So your x is 0. Now, if your x is 0, why wouldn't be? So y is 3, and you really don't even need to show work for that. Okay, so and this would also be known as your y-intercept. So, okay, so that's how you would do something like that. All right, I want you to do number 6 on your own, and then we'll get down to the word problem. So I'm going to pause the video for you to work on number 6. Okay, let's check number 6. Make sure you complete that correctly. See, this isn't too difficult, right? You just kind of follow the same method over and over again. Huh?
What's examples?
That is a word problem. Do you remember the word problems from the previous lesson, the following objects? So if you,
Yeah.
yes, it was. I'm gonna try to maybe simplify this a little bit. So let's go ahead and look at example 7. This one is the vertical motion model, so it's a little bit different. So during halftime of a basketball game, a slingshot launches t-shirts at a crowd. Okay, a t-shirt is launched with an initial upward velocity of 72 feet per second. The t-shirt is caught 35 feet above the court. How long will it take the t-shirt to reach the maximum height? What is the maximum height?
72. 35.
Yes.
72. It's traveling.
Say that again.
Traveling 72 feet per second.
Yeah, but it's caught at 35 feet. So just because it goes 72 feet per second doesn't mean that it's at 72. That just means how fast it's going. It would be like me driving down the road, and when I start going, and then I set my cruise for 60 miles an hour. I'm not at 60 miles yet, but I'm going that fast. That's kind of how what this is talking about. So it's caught 35 feet up in the air. So that's our maximum height. But it's not asking for the maximum height. That's what they give us. They want to know how long does it take when it goes 72 feet per second to get to 35 feet. And then what is the maximum height? We know that. What is the range of the function that models the height of the t-shirt over time? Okay, so we know the scenario, right? They're launching t-shirts in the air to the crowd, kind of like how we do with our pep rallies, and they launch candy up in the crowd and we catch it or whatever, they toss it over. So to solve this problem, use the vertical motion model h equals -16t squared plus vt plus c, where h is the height of an object, so where it is at a certain time, in feet after t seconds. It is projected into the air at an initial height of c. So that part is what we already have been working with in 8-1. We've already worked with time and with the initial height. What we haven't worked with is the second point, our initial velocity. So also, when something is being launched at some point above the ground and no initial height is given, we will assume it's 5 feet if a person is throwing or tossing it. So they do not give us the initial height here. We're assuming somebody is launching it from their height, and we're assuming that the average height is 5 feet. Is the average height 5 feet? I don't know, but that's what we're going to assume. Okay, does that make sense? So somebody is launching a t-shirt. We're going to assume they're launching it from an initial height of 5 feet. I'm about 5 feet 6. I really don't know that 5 feet is average, but anyway, they're launching it from 5 feet. And when they throw it, or when they launch it from the slingshot, it goes 72 feet per second, and it is caught 35 feet in the air. Okay. So the first thing that we're going to try to do here is we are gonna figure out how long it takes to get to its maximum height of 35 feet. Yes, you're figuring out for the t. So in this equation, and it has everything to do with what we just did. In this equation right here, negative 16t squared plus vt plus c. Let's go ahead and write out this equation and plug in what we know. Okay. We have h equals negative 16. Do we know the t squared? No, we don't know what our t is. Do we know the do we know the velocity? Yes. V is 72. We know the initial height. Oh, yes, we do. But we're going to hold on to that for just a second. Okay. And then we don't know time, like we said. And what was the initial height? 5 feet, because we're assuming that it's 5 feet. Okay. Now, if we wanted to know the time that it takes, so we want to know t, and I want to write this equation up here, y equals ax squared plus bx plus c. Okay. There's two ways that we can find this. We can find it using the vertex for the axis of symmetry formula, or we can plug in 35 here and try to solve. But if we were to plug in 35 here, it's very difficult because we have a t squared and a t. So we're not going to do it that way. But look in here, how did we find x in our equation and all those problems we just did? Yeah, we use the axis of symmetry equation. So that's what we're going to do here. We're going to use the axis of symmetry is x equals negative 1b over 2a. But instead of saying x, we're going to say time, because time represents our independent variable. That is our x. So we're going to put time equals negative 1b over 2a. And we're going to solve for the time. Very simple, right? That's what we're going to do to solve for time. Okay, so let's plug this stuff in. We have negative 1 times, what is b? Over 2, what is a? Negative 16. Now remember, you guys can use calculators in this chapter. All right, so we have negative 72 over negative 32. And if we were to simplify this, we really don't need to, but if we were, we could divide both of these by 8 and get 9/4. And then you could just plug in your calculator. 9 divided by 4 is 2.25. So our time is 2.25 seconds. Okay.
That's fine.
Huh?
That's fine.
That's one of our answers. They're asking a whole bunch of stuff here. How long will it take the t-shirt to reach its maximum height? 2.25 seconds. What is the maximum height? No, we want to know if it goes. No, we're going to find our height right here. Watch. H equals negative 16, and we're going to plug in our seconds here. Okay, so we're going to plug in 2.25. They caught it at 35, but that wouldn't be the maximum height it would go at that velocity. Does that make sense? Okay. Plus 72 times 2.25 plus 5. Okay. So we're going to go ahead and solve this. So earlier I said we knew the maximum height. I was wrong. That was the maximum height that went because it was caught. But if it wasn't caught and it kept going, they want to know how high would it reach before it started falling back down? So -16. Now, if you're using a regular calculator, there is a difference between the negative symbol and the subtraction symbol. So right here, I'm using this. This is the negative symbol. This is subtraction. You don't want to use the subtraction symbol because then it will subtract it rather than multiply. So -16 times 2.25 is -36. Is that right? Oh, I have to square 2.25. I'm so sorry. I'm like, that does not sound right. Sorry. 2.25 squared. Okay. And then I'm going to take that and I'm going to multiply it by -16. Huh?
What's 2.25
It
squared?
was like 5 point something. So I get -81 right here. And then I'm going to add that to 72 times 2.25. 162 plus 5. And so we get 81 plus 5, and the height is 86. Okay. So our maximum height is 86 feet. And then it asks for the range. Okay. What is representing the range, the height or the time? The height is. So when we write out our range, what is and the range is your height, also y. What is the lowest height that the t-shirt is? What's the lowest height that our t-shirt is?
5 feet.
5 feet, okay. Some may say 0 because eventually it'll fall to the ground, but we're gonna just say 5. And then what's our max height? 86. And so then this would be your range. So all of this right here answers that question. Okay. And I believe that on the homework, the problems are similar to this. So you should be able to follow this. And I believe it's going to ask you to graph it also.
What's that?
Okay, that concludes our lesson for 8-2.
That would make sense.